I think I'll get started. So maybe I'll just sort of start by giving an outline of what I'm going to do here. I've never actually given a presentation on like this on Awk before, so we'll see how it goes, and hopefully you guys can give me some feedback after. But I'm just going to start by showing some PowerPoint slides, just giving sort of a high-level overview of the package and some of the motivation for building the R package. And then after, I'll sort of go through a workflow as though I was somebody who had kind of never used or even downloaded the data. I'll kind of go through all the steps for sort of just a very simple exercise of pulling some data from this EBD. And then at the end, I mean, it's definitely not going to take 2 hours, or at least I hope it's not. So at the end, there should be plenty of time for questions, and then you're always welcome to email me directly at any point in the future with other questions. And as I was saying before, I think this is going to be a little bit more of like a demonstration. But if you fill out that Google form, and there's a link to it in the chat box, with your email, I'll send out all the code and everything after, so you can try to run through the stuff yourself, in the coming days. And then if you run into trouble, you can send me an email then. Okay. So with that in mind, okay. So hopefully you can see. Oops. Hopefully you can see this PowerPoint presentation. So I'm going to be talking about Awk, which is the name of this R package that we built here to extract and pre-process the eBird data. And I probably don't need to tell you guys too much about the eBird database. I think probably most people here have used eBird and are kind of aware, but I'll just give you some motivation for why it's a cool data set. We just crossed 500 million observations, I think, last week. So 500 million bird sightings now in the database. There's data from 253 countries, so like essentially every country in the world has data, and 10,374 species at last check. So most of the species on Earth are represented by at least one record in the database. So it's a super cool data set. It's, I guess, probably pretty unprecedented in this world. So the question is, how can you get access to the data? It's supposed to be open access data, but it's a bit hard to work with just because of the size. So that's what I'm going to talk about today. So the way that for the past while and for the foreseeable future, the lab is publishing this data, if you want the entire data set, is via this thing called the eBird basic data set, the EBD, which is a text file, a tab separated text file that has there's some exceptions, but almost all of those 500 million eBird observations. Each observation is a line in the file. And this file is updated roughly quarterly. And in addition to the observation data, there's also this other file called the sampling event data file, which is also a tab delimited text file. And that file just has checklist level information. So every line is a checklist, whereas in the EBD, every line is an observation. So it's a species within a checklist. And you see here, the file's pretty big. This is the compressed size of the file. So it's like 25 gigabytes compressed, which is pretty huge. But then when you download it, you'll see that it's a lot bigger. When you download it and you extract it, it's getting up towards like 200 gigabytes. I mean, it's a massive file. I've never dealt with a text file that big before, so it poses all sorts of challenges. So I think most people would probably either go to something like Excel or something like R to work with a tab delimited text file like this. But in both cases, you just can't. I mean, they just can't handle it. Like Excel will definitely just not even open the file; it'll crash. R will probably attempt to, but the thing with R is that it reads. It's everything is done in memory, so it will try to read all 183 gigabytes into memory, and no one's computer has that much memory, so it just won't work. So we need to make this file smaller. We need to sort of subset it out, extract out just the records we need, and make the file small enough that it's manageable, and we can use it in some of these other these tools that we're used to using. So what people at the lab have been using for a while, and I guess a couple years ago they taught a sort of a workshop at NAOS, I think in 2016, on this method. So there's this old command line Unix utility called awk, which is kind of like a scripting language that's specifically for processing delimited text files. So it allows you to subset out columns or rows based on all sorts of criteria. And it's really fast and it's really powerful. But it does mean using the terminal, which a lot of people don't love. And it also means writing on the right side of the screen here. I've just given an example of what awk code looks like. So you'd have to learn this whole new sort of scripting language, and there's a whole variety of reasons why it's sort of a pain to actually try to manually write these scripts. So when I came to the lab about a year ago, I didn't feel like dealing with that, so I decided, well, let's just write an R package and get the R package to write the awk code for you, run it in the background, and then spit out a text file. So that's essentially what this awk AUK package is it writes awk AWK scripts. And then there's some other tools as well built into the package, but that's the majority of it. It writes awk scripts that will run and extract a subset of the data, and then hopefully that subset will be small enough that you can read into R. So essentially there's like a 5-part workflow, or sort of 5 things that awk does. The first thing is it can clean the raw data set that you downloaded. It can filter to extract out subsets, import the data into R, do some pre-processing, and also this thing that I'm calling zero filling. So the cleaning is just, there are some rows in the data set that are problematic. Particularly the comments fields are included in the database, or in the text file. And those are totally free text, so people can put anything in there. So there may be some characters in there that when you try to read in the file, it causes problems. So this cleaning function will get rid of some of those rows. And also, in most cases, some of the sort of free text fields, like the name of the location, the name of the observer, the comments, they're probably not necessary. So the cleaning function also has the option of just getting rid of those columns, which will decrease the size of the file, and then which is good in of itself, but also will speed up processing later down the line. The real meat and potatoes of the package is this filtering, the set of filtering functions. So the idea is extract just the stuff you need. You don't need, in most cases, you're not going to need data for the entire world for all the species. You might just need one region or one species or one time period. So you extract just those records to reduce the file size to something manageable. And then you may want to do something like that. Maybe the end of awk for you. You may want to bring the data into Excel or some other tool. But I think for a lot of people, they'll want to do further analysis in R. So there's some functions for reading the data into R, bringing that text file into a data frame in R. And you could always just do that with however you normally read text files, but this has the benefit of sort of cleaning up the names nicely and giving sensible data types, converting the dates to dates and stuff like that. And then there's sort of two important pre-processing steps that the package does by default when you read in the data. So the first is collapsing group checklists. I assume probably most people here are on this call are birders and have probably used eBird. But for those that aren't, you go out birding, you create a checklist of the species you've seen, and there's an option if you're birding with other eBirders to share your checklist. So this is on this slide now is a particularly complicated example where it looks like there's, I don't know, like at least 10 different observers who all were out birding together. They're all eBird users, and one person made the checklist and then shared it. And it gets complicated because you can see here that there's some species like these couple at the top, the wood duck and the widgeon, that were seen by everyone, but then there's other species that were seen. Katie also saw a coot and a goldfinch, and Mark saw this blue-gray gnatcatcher. So there's you can have these sort of messy checklists that are shared between multiple people, and as a result, they're duplicated in the database. And some people have seen some birds, and some people have seen other birds. So this package deals with that, and I'll talk about that more later. And then the other thing is dealing with taxonomy. So eBird, essentially, you can report any sort of field recognizable taxon. So that can be things like you have hybrids like this mallard and black duck hybrid. You have different recognizable forms. You have intergrades like hybrids between subspecies. You have things like Audubon myrtles warbler complex or whatever. You have feral species. You have also just spus. So like this on this checklist, there's 200 duck spa. Sometimes you even see just bird spa. So there's all sorts of taxa that are not species. And for most analyses, you probably just want to deal with species. So when you read the data in, the package has an option to sort of roll up all the taxa that are below species up to the species level and just remove things that aren't identifiable to a single species. And then the last thing is when you're just dealing with the EBD itself, that's where every row is one observation. That's like presence only data essentially. You just know which species were seen where, but you don't know where they weren't seen. But eBird has this concept of a complete checklist. So when you submit an eBird checklist, you can check a box that says, I'm submitting a checklist of all the species I've seen or heard. So if someone clicks that box, they've filled out the sort of explicit counts for the birds that they saw, but then implicitly every other species is 0. And those zeros aren't explicitly recorded in the database. But if you just work with complete checklists, and then you have I mentioned before, the sampling event data is the list of all the checklists, you can sort of use that sampling event data to fill in the zeros. If a species has no count on a checklist, it gets a 0. And this package also has functions for producing this 0 fill data, like presence absence data, which you could then use for things like species distribution modeling. Okay, so before I jump into the demonstration, just some places to go for help. There's a pretty detailed vignette for the package at this link here, which goes in detail through pretty much everything I'm going to talk about today. If you think there's a bug in the package, there's some problem you're encountering, feel free to go to the GitHub page and file an issue. If you just have a question, like you don't think there's a bug, but you're struggling with something, feel free to send me an email anytime, and I'll try to get back to you as quick as I can. And lastly, I'll, as I mentioned before, I'll put these slides and the code from the demonstration up on another GitHub repo, which you can then look at. Okay, so I'm gonna end that. I just have to figure out how to unshare this. Oh, also I am recording this, so presumably this will go up at some point for people to look at. Okay. Okay, so hopefully everyone can just see my whole desktop now. Actually, while I'm here, I'm just gonna, okay, so you should be able to see my browser. So I'm just on the eBird page. I'm just gonna sort of kind of walk through from the beginning how you would download the data and then go about extracting and processing it. Probably everyone at this point has already done this, but you go to the eBird page, you click the Explore link, go down to the bottom of the page and click on this Download Data button. And then the eBird basic data set is what you're interested in. Now at this point, folks that haven't requested access yet or have requested it but haven't been granted it, you'll stop here. So if you haven't requested access, request the access. If it doesn't come through in, say, a week or something, send me an email and I'll see what's going on. But once you get access, you'll be able to download these two files. So download the files. I won't do it because I already have them. Also, it's probably worth mentioning that these are released quarterly, so it's worthwhile if you still have the access, come back once a quarter and get the fresh data. So once you download that data, so this here is that file. I don't know if you can see this. It's the 183 gigabytes for the main EBD, and then it's 9.41 gigabytes for the sampling event data. So they're pretty huge files, and I'll just show an example of. I'll just show an example of just what those files look like. So I just extracted the first 100 rows. So they're tab separated files. They have all the information that gets recorded when someone submits an eBird checklist. So you have this is the EBD here. So you have the species, you have counts, you have all sorts of geographical information, state or country, state, county. You even have like breeding bird atlas codes. You have the BCR code. Also, and obviously, just a Latin long. Date, time. All sorts of effort information like number of observers and how long the checklist was. So it's this very long file. It's got something like 48 or 50 columns. That's the EBD, and then the sampling event data file is very similar. it has basically just a subset of these columns. So all of the columns that don't relate to the species, that they just relate to the checklist, are in this file. So there's a lot. This file is a lot smaller because there's a lot less rows, because every row is a checklist as opposed to every row being an observation. So that's what these files look like. Just if you're curious in general, you probably won't ever need to actually like open these up and look at them in a text editor. Okay, so I'm going to close that. And now I'm just going to pretend like I was starting a whole new project. So I open up RStudio. I'm going to create a new project. Okay. So this is just a blank project. So I'm just gonna kind of work through those 5 steps, the cleaning, filtering, importing, and so on, in kind of real time. But before I start, a couple things worth mentioning. I always forget to say this because I have a Mac, but for those of you that have Windows, this awk tool, the AWK, this Unix command line utility, you don't have that by default. Mac and Linux users do, but Windows users will have to install this thing called Cygwin, Cygwin, and it's just basically it's a Windows tool to allow you to use Linux utilities. So once you install that, everything else should work. The package is set up to sort of just work seamlessly. So install that, and everything should be good. And then the other thing I wanted to mention, just this morning, I think I sent an email earlier this week asking people to install an updated version of awk. And then just this morning, I found a bug with awk that affected this thing that I'm about to do. So after this presentation, or right now, install a fresh version of awk. And it's on that the new version I released today is already on CRAN, so you can install it just using install.packages. packages. Okay. Okay, so actually maybe now's a good time to just stop for a split second and ask if there's any questions. Is anyone like totally confused? Okay. All right. So the first part of that 5-step workflow is the cleaning. So I'm going to sort of split each of these things into different R scripts. So we'll start by loading the awk package. And then what I always do, when you download the EBD file, you have to download it and then extract it. Find somewhere central on your computer, or it can also be on an external hard drive, to put the file, and then remember the path. I would actually put although you download them separately, I would put the sampling event file and the EBD file in the same folder, and then all your scripts can reference that one folder. And I just have to get the directory to that folder. Okay, so I recommend just putting having a variable where you store the path to the folder that contains the EBD. I think that's probably the easiest thing. Okay, so for the cleaning, you're only going to do this one time right when you download the data, and then you don't have to worry about it again until you download another copy of the data. It's pretty simple. You just do, first I'm going to set up paths to the EBD, the original EBD file. So this is just now a variable that stores the path to the EBD file. And then you need an output file with the cleaned data. I usually just append clean to the end. And then the command is awk auk underscore clean, and then the input original uncleaned file, followed by the output desired output clean file. And I'm also going to use this remove text equals true, and that will remove those free text columns and decrease the size of the file. Now I'm not actually going to run this right now because it's probably something just worth mentioning right off the top. Like anything, all of these functions that involve awk, doing something to the full data set take a long time. Like this will take probably 2 to 3 hours to run. So I've already done it, so I'm not going to do it. But this is what you would do. And then you would do something similar for the sampling data. Sampling data has almost the same name, just has sampling in it. Okay, so you'd run these each sequentially. It's going to take a while, but then after that you don't have to do it again. And I'll just show you. So this is what before the file was 183 gigabytes, and after the cleaning it's 139 gigabytes because it removed all those text columns. So it's a bit smaller. So that's the end of the cleaning. The next step is the filtering. So I'm going to put it into another R script. That way each sort of step is self-contained, especially because you're not going to run that cleaning one again. I constantly am restarting my R session to clean out all the variables. So I'm going to load my packages. In addition to awk, I'm loading the tidyverse, which I imagine probably most people are familiar with, but it's just a set of packages. ggplot and dplyr are kind of the two most well-known, but it includes a whole bunch of other packages as well that are really good for sort of just manipulating and cleaning and analyzing data. And then I'm also going to bring in that same path where I've centrally stored these this EBD file. So I'm just gonna switch the sharing so it just shows this particular screen. Okay. All right. Okay. So I'm just dealing with limited screen real estate here. Okay. So like I said before, the working with the EBD is like it's like a a war against file size. So the point of the filtering is to just get out stuff that you just the stuff that you need, so the file is small enough. And so I'm just gonna, I have here the paths to the to those cleaned files that I made in the previous script, because those are the files that I'm going to need to work with to do the extraction. There's a whole actually, okay, so the first thing before you do any of the cleaning, there's this function awk_ebd, and you pass it the EBD file and optionally the sampling file, and we'll get into the importance of also passing in the sampling file later. I'm going to run that. Oops. So what that does is it creates an object that points to these big text files, and it also stores, if people look in this bottom left pane, it stores all the filters that you're going to define. Right now, I haven't defined any filters. I've just sort of set it up. So you can see it lists all the potential filters, but there's none of them are actually doing anything yet. And to get a complete, there's a whole bunch of different things you can filter on. And maybe I'll bring up the vignette, because the vignette shows you the full list of filters. Actually don't know if I did what I was trying to do. Sorry. Okay, so if people should see this list of filters, and if you don't, someone should. Okay, so you have, I'll just go through sort of from the top. You have species. You can filter by species, country, state, extent. That's a geographical extent, a latitude, longitude bounding box. Date, last edited is not important. Protocol refers to whether it's like a stationary or traveling count or just an incidental observation. This project filter, there's various and assorted different projects within eBird. So like breeding bird surveys are an example, and they each have a special code. So that allows, if you're doing one of the breeding bird surveys, it allows you to extract just that data. And then there's some effort filters. So you can filter by the time of day that the checklist started. You can filter by the length of time the checklist lasted, the distance that the observer traveled. You can filter to only retain records that have a breeding bird atlas code associated with them, if you're interested in that. And then finally, you can just extract the complete checklist, which is something I talked about before. Okay. So we're going to sort of set up some of these filters. Before I do that, it just occurs to me that I probably need to explain what the pipe operator is, because I'm going to be using it a lot. It's this thing that I just created on a Mac. The shortcut is Command-Shift-M. It's a really great way of making your code a lot more readable. It's called the pipe operator. It's a %, a greater than sign, and then another %. Essentially, it just takes whatever's on the left and puts it in whatever's on the right. So say you have, on the left, I have like just the numbers 1 to 10, and then I want to take the mean of those numbers. I can run that. It gives me 5.5. That's exactly the same as doing this. And it allows you to, you can chain together, a whole bunch of these steps, and it prevents you from having to sort of nest function calls, and also prevents you from it also prevents you from well, I forgot what I was going to say. Okay. Hopefully you have some sense for what that is, and I think as I use it more, hopefully you'll understand it. I usually read it as then, so it's like, generate the numbers 1 to 10, then take the mean. Okay. Right. So I now have this object that references the cleaned data sets, and I'm going to start defining filters on that object. So let's just say, for the sake of argument, I want to look at thrush. So we want to look at Bicknell's thrush and Swainson's thrush. So we can run this to start, and you see already it, again, in the bottom left pane, now it says that we want to be extracting those two species. With all of these filtering functions, they all begin with the letters AUK underscore, and then they have the thing that you're going to filter. So in this case, awk underscore species, and they're also sort of, I've tried to make them sort of as smart as possible. So you can with these species, like you can make them lowercase, and it will still get the right species. You can also put in the scientific name or the common name, and again, it will still find the right species. Another thing it will do, though, is if you misspell a species, it will give you an error, and it will tell you that species that you tried to put in was not found in the eBird taxonomy. This package comes with a built-in copy of the eBird taxonomy that it checks against. So a lot of these filters have checks associated with them. The benefit of that is that it tries to catch the errors before you actually try to run this 2 to 3 hour awk script. At this point, we're just defining the filters. We're not actually running anything. So I'm just going to go back to Swainson's thrush. Okay. And let's say that we're just interested in records from New Hampshire, which has my favorite mountains in the Northeast. And let's say we want to, just look at records from June. So for the date, you can put just a normal date range, but you can also use, so you could be like, 2016, 0601 to 2016, 0630. So that would extract records from June of 2016. But for the year, you can also use a wildcard. You can put a star. That will extract records from any year, from any year on these dates. So this will get records from June of any year. And then let's also just, often it's nice to use these complete checklists only, and I'll talk about that more later. So these are the set of filters I'm going to use. Bicknell's and Swainson's thrush from New Hampshire, from June of any year, on complete checklists only. So I'm going to call that something. So as of yet, nothing's actually been done. It's just defining these filters in this object. But to actually do the filtering, to write that awk script in the background and then run it to create the text file, It's a function called awk_filter. And you give it, as the first argument, you give it this object that references the input files and defines the filters. And then you also have to give it, output files. In this case, 2 output files, one for the sampling data and one for the EBD. And what's going to happen here, because I've also given a sampling event data file in addition to the EBD file, is it will apply the exact same set of filters to both files, obviously minus the species filter, because sampling event data file doesn't have species information. Okay, so if I were to run this, it will go away for like 2 to 3 hours probably. It'll just chug through that massive 180 gigabyte text file, and then eventually it will spit out just this smaller subset of data. As with the cleaning, I'm not actually going to do this right now because I don't want to sit here for 2 hours. I did it this morning. So we're just going to pretend that it's already been done. I'm going to just point out one other little thing here. It's not really awk related, but I think it's good to keep the EBD in a central place because you just want to have one copy that you reference in various projects. I would tend to keep the output, like the filtered data within the project, the RStudio project subdirectory. And the nice thing about that is that then you can always, RStudio projects always set the working directory to be the project directory. So you can just, as with this line of code here, this is saving it in the data subdirectory of the project directory. And I can just always use relative paths. And then it makes your code a lot more portable, because the only thing someone's going to have to change is the EBD directory, but then all the subsequent outputs, if they're all within your project directory and defined with relative paths, it will make your code totally portable. Okay. Okay, so I'm going to make, okay, so I'll just, I'm just going to find these files that I already generated. So this is them here. I hope y'all can see this, my screen. So we went from the 183 gigabyte file to an 800 kilobyte file. It's tiny. And then the sampling event data is less than 3 megabytes. So this is super manageable. You could open this in Excel or in R or in anything else. So I'm just going to copy those 2 files. And then just going to paste them into the project I'm currently working on and pretend that that was the output of the code I ran. Okay, and now I'm going to create a new script. Well, maybe we'll call it analysis. And the reason I'm doing this is because, just again, to keep things self-contained, this filtering step takes a long time. You probably, you're only going to run this, occasionally, probably maybe even just once for a project. So you run the script and you have to worry about it, and you can focus on the analysis script, and that will be self-contained. So again, I'm going to restart R to clean out my whole environment. And then we're going to talk about importing the data. I'm just going to switch back to sharing just that screen. Okay. All right, so again, I'm going to I'm going to load those two packages. I didn't turn out I needed tidyverse. Okay, so I'm going to load those two packages. Now I don't need to reference the sort of master directory of the full EBD because I'm not going to use that anymore. So that's nice. I don't have to worry about that. Now I'm going to use this function. I'm going to talk about sort of importing the data into a data frame in R after you've filtered it. And again, you could use any number of sort of other functions to do this. But read.delim is like the base R way to read a tab separated file. But if it's worthwhile using the functions that are built into awk for reasons we'll see in a second. Oops. So read EBD is the function to read an EBD file. You just give it the path to the file we just created, like the filtered file. Okay. And then, well, let's just open this up and take a look at it. Okay, so you see it's made the file or the column names sort of nice R names, all lowercase, separated by underscores, which I'm convinced is the only way to name variables. That's potentially controversial. The original file has uppercase and spaces between the components of the names, which obviously R can't have that. It also it does things like converts. There's like some columns that are ones and zeros, which really means true and false. And it, like this is an example here, and it converts that to true and false. It also like the date field that converts it to an R date and stuff like that. So you can also use this glimpse function. You can see all the. So we have 2,253 records of Bicknell's or Swainson's thrush in New Hampshire in June from complete checklists. And we have 42 variables. Okay, so that's sort of like, I mean, the reading part is pretty trivial. What's actually interesting is sort of the pre-processing steps that happened automatically when I read that file in. And they're the two things I talked about earlier: the taxonomic rollup, as well as the handling of group checklists. So I'll talk about the taxonomic rollup first. This is right. So eBird has a page all about the taxonomy. We maintain this annually updated taxonomy of species, as well as all sorts of other field recognizable taxa. There's 8 different categories that they fall into. You have spurs, slashes, normal species. You have hybrids, domestics, like recognizable forms. And essentially what this by default, when you call read_EBD, it removes anything that's not identifiable to a species, and then anything that is below species, it brings them up. And I'll give some examples of how that works. And so for the roll up, if we look at you can look at the help for read. So you can see in this help file for read underscore EBD, there's these two flags which are true by default. One is rollup and one is unique. So if you just wanted the raw data without taxonomy dealt with and without group checklists dealt with, you could say rollup equals false, unique equals false. And you could read the data in like that. Okay. So anyway, I just want to give an example of what's actually happening with that roll up. And there's sort of two things I want to show. The first is just the fact that the package comes with a copy of the taxonomy. Actually, maybe it's better to do this. So within the package, you have this full list of all the different taxa that eBird, right, that people can report species or report on in eBird. So that could actually be useful for other purposes, and it's used for this roll up. And the other thing I want to show you, the package comes with a few example data sets that are just tiny extracts of the full EBD that allow you to sort of play around. One of them, you access them using the system.file command, which just, you can look here, just gives you the path to the text file that's stored within the package. So one of them is specifically designed for looking at this roll-up issue. So I'm going to read in this example data set, and I'm going to put rollup equals false to turn that off. And then I'm going to store that as the data frame, and then I'm going to call this function awk underscore rollup, which does the rollup. So if rollup equals true in read underscore EBD, it will call awk underscore rollup. So now I have these two data frames. One has had the taxonomic rollup applied and one hasn't. And then we can look at a few different things, like we can look when the rollup hasn't been applied. If you look at the bottom left pane, you can see this list of all the different sort of categories of taxa that are included in the data set. So you have domestic, form, hybrid, integrate, slash, SPO, species, and ISSF, which is I'm not exactly sure what that means, but I guess this is some kind of recognizable form. But if we do the same thing, I'm going to do the same thing now with the data frame where the rollup has been applied, and it's just only species. So everything above species has been like American slash or mallard slash black duck has been like stuff like that, and SPUs have all been removed. And then another cool thing that you could easily probably do yourself, but probably the more interesting thing is if we look. So again, if you look at the bottom left pane, I'm just looking at the rows in that EBD file corresponding to yellow-rumped warbler, and you have this one checklist here. These three records have the same checklist ID, where someone saw one myrtle, one Audubon's, and then 10 that they couldn't tell whether it was myrtle or Audubon's. So that's in the unrolled up file, the raw file. But if I do exactly the same thing for the file with awk underscore rollup applied, see now, it's bigger. Now there's just one record. So, and in addition, the counts have been summed. So now instead of 10, 5, and 1 for the three different types, you just have 16 yellow-rumped warblers. Okay, so that's kind of all I'll say about this roll-up function. I think in most cases, you probably just, I mean, it happens by default when you call read underscore EBD, and probably in most cases, I think that's sort of like a sensible behavior for it to have. But you can always turn it off, if you want to look at subspecies or higher level taxa. Okay. And then the next thing I'm going to talk about is this next pre-processing step, which is a bit simpler, is dealing with group checklists. So in the slides before, I sent an example of, I had some images, some screenshots of an example, but I'll just share my browser with you, and you can see this is the actual checklist on eBird. So you have all these different people. Say there's 10 different observers, and they each have a copy of the database, a copy of the checklist in the database. So this, if they had all, if just ignoring if you just focused on the species that they all saw, there's essentially like 10 duplicates of, or actually, I guess the party size was 11. There's 11 duplicates of these observations in the database, and in most cases, you wouldn't probably want to have that kind of duplication. You would just want to have these people these aren't independent observations; they're all birding together. You would probably just want to have one record as opposed to 11 records. But then in addition, you have, as I scroll down, you see this is a super complicated checklist because you have almost everybody on, or maybe half the people saw some species that the rest of the group didn't see. So you have, additional species seen by these various and assorted people. So some of these records, the ones at the top here, will be duplicated 11 times. Others will just have one instance, or maybe some, and it could be any number between 1 and 11 times in the database. So I'm going to go back to the R window. So when you're using read underscore EBD and unique is equal to true, this function awk underscore unique is called. So I'm gonna read in the EBD just raw, with no removal of group duplicates. And you can see here the file has 2,613 rows. And then if I manually call awk underscore unique, it will do this deduplication of group checklists. It has 2,000, right here, 2,253 rows. So that, that decrease of 60 or something rows is because duplicates have been removed from this data frame. So those two things, the taxonomic rollup and the group checklist deduping, all happens by default behind the scenes when you call read EBD, but you can also choose not to do those things. And then they each have functions, awk underscore rollup and awk underscore unique, that will sort of, if you want to manually apply those things. But in this case, let's just say we want to apply those, so I'll just read in the EBD. And similarly, you can read in the sampling file in almost the same way, read underscore sampling. I don't remember what I called this file. Okay, so now I've read in both files. The sampling file, there's no species information in that file, so the taxonomic rollup doesn't apply. However, the group checklist deduping does apply. And again, here's what the file looks like. So we have 12,938 rows. And this brings up the final point I'll raise about in this section. If you look over here in the actually, I'm going to restart my R session. quickly run this. So if you look over here in the right pane, sorry, the top right pane, you see that the EBD, the filtered EBD has 2,200 rows, and the filtered sampling event data file has 13,000 rows. So in the raw EBD, the EBD is way, way bigger than the sampling file. But it's often the case that when you pull subsets, the sampling file is bigger, especially when you have taxonomic subsets. And the reason for that is just that, especially with something like a Bicknell's thrush, most checklists in New Hampshire in June don't have Bicknell's thrush. I mean, only those checklists that have where people are probably at high elevation are going to have Bicknell's thrush. So as a result, this 12,000, this 13,000 or so number, that's all the checklists in New Hampshire in June that are complete. And then the EBD is just the records that had those two species on them. And the reason that's important is because, say you were wanting to pull, actually just recently, someone that does research in Costa Rica sent me an email, and they were trying to pull timberline wren data, and they just put one filter, like the species filter for timberline wren, and the EBD was tiny, but the sampling event data file was huge. It was basically the exact, like, the species filter doesn't apply to that file, so it was the same size as like the raw file, essentially. So the reason I bring that up is because you, even if you're looking at a species that you expect is going to have, like if you're just filtering by species, it may also be worth applying some geographic or temporal filters as well. Even though it won't maybe matter for the species, it will decrease the size of the sampling event data file, which will speed up, which will make it a lot easier to work with the files later on. Hopefully that makes sense. And then maybe at the end, someone can ask me a question if it doesn't make sense. Okay. So the last thing I'm going to talk about is this zero filling business, but maybe I'll just stop here. There'll be, I think, lots of time for questions at the end, but are there any kind of really critical things right now that people want to ask? Or is everyone just totally confused and lost? People can feel free to use the chat window if they don't want to unmute themselves. Okay. Not getting anyone telling me to stop, so I'm gonna continue. Oh, all right. Thanks. Somebody just said they're getting it, so that's good. I just was looking for some kind of feedback. Okay. So okay, now we have these two files, the EBD and the sampling event file, or they're actually data frames now. There may be a lot of cases where just having presence data could be good enough. Oh, someone just unmuted themselves. Is there a question? No. Okay. So if you just wanted to make a map of Bicknell's thrush locations, you could just use the EBD as it is, and there's various other sort of applications in which that would, like, that data set alone to be enough. But there's a lot of situations in which having presence absence data is really critical, where you want to have both the ones and the zeros. And this is the last thing that awk can do for you. So I think I've sort of mentioned this in passing throughout this presentation a couple of times, but I'll explain again. First of all, there's this concept of complete checklists. So if somebody's submitting a complete checklist, it means that they're reporting all the species they've seen or heard. So they're actually only explicitly reporting the species they saw, but you can assume that every other 10,800 and whatever species is essentially a zero. Like it's an implicit zero, and so we can use those implicit zeros. We can make them explicit, and then essentially create a presence absence data set, which we can use in things like species distribution modeling. And this is kind of why it's, if you remember, if we go back to this filtering script, it is possible, it's in this awk_ebd call, I can choose to just give it the EBD file, not the sampling file, and then you can just filter the EBD file alone. But the reason it's important to, in many cases, to give it, as I've done here, both the EBD and the sampling file, is it ensures that exactly the same set of filters have been applied to the two files, because you need to be sure that the filtered EBD is sort of like referring to the same population of checklists as the sampling event file. So in this case, you want to have, we've extracted checklists from New Hampshire that are complete from June of any year. And the EBD has that set of checklists, just the ones that have either Bicknell's or Swainson's thrush, but the sampling event file has all those checklists. So it's like, if a checklist, say looking at Bicknell's thrush for the moment, if there's a checklist that is in the sampling event file, but is not in the EBD for Bicknell's thrush, we can assume that checklist has a 0 for Bicknell's thrush. So yeah, I guess I sort of think of it as like, you have some population of checklists, and it's important to make sure that both the EBD and the sampling event file are kind of referring to the same population. So that's why it's really important to filter them together. So I have done that. I now have these two data frames, one for each of those. And there's this function awk_0fill. The first argument is the EBD. The second argument is the sampling event data file. Let's call this 0fill. I'm going to run this. Okay, so again, if you look down here in the bottom left pane, it says 0filled EBD 12,938 unique checklists for 2 species. So by default, this awk_0fill returns a sort of like a special object, and the object, if we go up here to the top right pane, we can inspect the object. It's essentially just it's just a list with 2 data frames. One data frame stores the checklist information, and the other data frame stores the observation information. So we can dig into those data frames. So let's look at the observation information. So we can go ZF is the name of that we've assigned to the object, and then we can access the observations element of that list. Let's run that. Okay, so looking at the bottom left pane, you can see we have just sort of the bare minimum columns here. We have the checklist ID, the scientific name of the species, the count, and then whether the species was observed or not. And then you'll notice here that several of these are 0. So if you were just looking at just the EBD itself, these 0 records would not appear. But this awk_0fill function puts those zeros in. So that's the observations. And then the other is the sampling events. And then this is a much bigger data frame. This is essentially the same as the sampling event data file. It's just the full list of checklists. And you can note that it has this on the far left here, this checklist ID field. That's the same as the checklist ID field in the observations data frame. So the two data frames can be combined using that field. The reason it's by default two data frames is that in this case it's not such a big deal, but if you had like 100 species, for example, then all of, there's 29 rows of checklist data that would get duplicated 100 times. So you'd end up with a much larger object. So it's more compact to store it as two separate data frames. But if you want to have it as a single data frame, you can use this collapse equals true argument. And then we can just view this. So this now has all the checklist information, and if we go over to the far left or far right, it also has the species information. And you see like every checklist record here, like these are the same checklist, the first two rows, but just two different species. Okay, so oh, and then also just for interest, you can also sort of manually do the collapsing. So if you didn't collapse the two, you could do it using this collapse _ zero fill function. Or in fact, if you wanted to, you could just, in however way you like, you could join like with dplyr or data table or something, you could join the two data frames together yourself using the checklist ID column. Okay, and then I'm just going to take like 2 seconds at the end here. I'm not going to kind of do this part of the coding in real time, but just for fun, I just have like 2 extremely basic examples of sort of like applications that you could potentially do. One with just the EBD, like the presence only data, and then one with the presence absence data. Okay, so I've just put in a whole bunch of other packages here. I'm gonna load those packages and then load up the data. And then hopefully this works. So say we could use the presence only data to create a map of observations in June in New Hampshire of these 2 species. So we can start by we can sort of turn the EBD into a spatial object using this SF package. I'm going to post all this later, so I'm going to go pretty fast, so don't worry too much. You can delve into it on your own time. And then there's a package called R Natural Earth, which you can use to get sort of all sorts of different global kind of like GIS data, including boundaries of countries and boundaries of states. So I'm going to download the state boundaries for the US and Canada, and then I'm also just going to filter that file or that object to just get the outline of New Hampshire on its own. And then I'm going to make the map. Okay. So I'm just going to start by plotting basically just the state boundaries. And then I'm going to plot the two different species on top of it. So hopefully this works. Okay. So if we look, so you can all see this. Oops. So here's a really quick map that you can make in R in 5 minutes, using these eBird data observations that we just extracted. This is just the presence only data. I forgot to put a legend on, but I mean, obviously these blue ones, I assume in the middle here is like probably the White Mountains. So these blue ones are going to be Bicknell's thrush, and then the green ones are probably Swainson's thrush. So obviously it seems like Bicknell's is, tends to be in this area where the White Mountains are. And then I'll just quickly make one other map. This time, obviously the problem with this is that we don't have any sense of effort. So, the fact that there's no observations down at the southern part of New Hampshire, is that just because no one's birding there, or did the species not occur there? We have no idea. So this is where that zero field data comes in really handy. So what I'm going to do here, the sampling event data file comes with, for every checklist, it's assigned a county. So I'm just going to start by summarizing the data by county, and calculating a frequency of observation within every county for the two different species. There's a package called Tigris that has county boundaries. That will download the county boundaries for you. So that's what that next bit of code did. And then when you have spatial objects in this, using this SF package, ggplot can actually plot them natively. So this last chunk of code here will make a map of the two. See what it looks like here. All right, so we have this map. On the left is Bicknell's thrush, on the right is Swainson's thrush, and then the coloring is a log scaled frequency of observation on eBird checklists. So it seems like Swainson's thrush is just overall like more common on checklists, and it seems like both species are actually just more commonly observed in the northern part of the state. Anyhow, I just wanted to at least have some sort of like simple application at the very end, so you don't just look at code, you can actually see some maps and stuff. But I think that's all I have to say. So I'm happy to answer questions now, or I don't know if people have other. I don't know. I'll just open it up to the group, I guess. Oh, I see. Okay, so some people are actually writing in the chat window here. Okay, so. Okay, so Kara is asking, you could also pull out a quick table of land cover types. So the short answer is no. There's another. Wait, I'm just going to switch to sharing my whole desktop quickly. There's two data sets that we release. One is this EBD, which I've been talking about today, and that's just eBird information. It's like a dump of the eBird database. However, there's this other, and that's released quarterly. If you go to the same place that we found the EBD, there's this other data set called the eBird reference data set, which I'm on the page for it now. This data set is what we use internally to, I think probably most people have seen we call them STEM maps internally. They're these animated black and orange maps of that show sort of weekly abundance. Like you can see the species migrating. To create those STEM models, we use this eBird reference data set. And essentially what this is it's a subset of observations that from the full eBird database. So for example, they have to be complete checklists. It's actually only in the Western Hemisphere. And there's a variety of other sort of filters. But the cool thing about this data set is that we also include with it for every checklist a suite. It's actually quite a large number of land cover variables. I think that's what Kara is referring to probably. So if you work with this data set, this is good for something like species distribution modeling, because it already has your covariates in it, and they're MODIS-based land cover variables. The problem with this is that there's no R package for this yet. So you're sort of left to try to figure out how to write your own Unix scripts to deal with it. I'm sort of in the process of trying to figure out how to write an R package for this as well. So hopefully that will be soon. Any other questions? Feel free to put a question in the chat window, or you can unmute yourself and just ask it. I assume, obviously this is just kind of a demonstration, so my assumption is probably that the real questions will come once people actually start trying to do this themselves. In which case I can just deal with those on an individual basis via email. Well, maybe while I'm waiting, I can share. Oh, someone just unmuted themselves. Was there a question?
No, that was just me, Kara.
Okay. I have a GitHub repo that has the course notes, which I'll update probably today or tomorrow. But I'll just paste in the. You should in the chat window now see the link to that, so folks can copy that link if they want. I guess I'll also paste in the link to the Google form if you want to just fill that out, just to give me your email address. In that way, I can send out that link to the GitHub repo, as well as if this video gets posted, I can send that out too. All right. I guess if there's no questions, we can kind of wind down. Let's give it like another minute or whatever. Feel free to bail on the call now.
Thanks so much for doing this, Matt. I think that almost everybody stuck in the whole time, so we're doing pretty well.
Right, it went a lot longer than I thought it was. I'm impressed people stuck around.
Yeah.
And hopefully at some point in the future, I think it'd be cool to have something in person, like at a conference or something like that, a workshop. I think this would work better if everyone was coding at the same time, and I could help people. But hopefully we'll at least get people started.
Yeah, and I mean, having just, I went from figuring this out on my own to having Matt walk me through this to working with the data on my own really quickly. So it is really straightforward. Sort of once you get past the learning curve is not difficult, and so it's been really exciting.
Yeah, and I'm quite happy to answer questions by email or just I can talk to you on Zoom or whatever, and you can share your screen and I can try to work you through whatever problems you have. All right, cool. Well, thanks everyone for sticking in there. And yeah, I look forward to it. If anyone has any feedback or anything, send it my way. All right, I'm gonna sign off.
Okay, thanks. Everybody have a good day.